Chapter 10, Section 2 is titled The Real Number System. So by the end of this lesson, you'll be able to identify and compare numbers in the real number system, and you'll also be able to solve equations by finding square roots. So first we have a little bit of a review. I would like you to put this chart into your notes, labeling each of the sections, so this may take you a little bit to copy this down. You can go ahead and pause the video to do that, but let's remember that an irrational number, which is over here on the right-hand side of this chart, is any number that cannot be written as a fraction. All square roots that are not perfect squares, whether positive or negative, are irrational numbers. And another common example of an irrational number is pi. Real numbers, then, are the sets of all rational and irrational numbers together. And we've talked a lot about rational numbers. Remember, those are counting numbers, zero, integers, which are positive or negative, and then any rational numbers, which are numbers that can be written as fractions. So a little bit of a review again. I want you to name all of the sets of numbers to which each real number belongs. So you're writing natural, whole, integer, rational, or irrational. So number one is a fraction. We have 21 over 7. But remember that 21 divided by 7 is actually 3. And so now we need to put all of the numbers that 3, or all of the sets of numbers that 3 is included in. And if we go back and look at the chart, 3 is actually a natural number. It's a counting number. And because this circle is inside the whole number circle, inside the integer circle, and inside the rational square, it's actually in every single one of those categories. So the number 3 is natural, whole, integer, and rational. All of the numbers we talk about are real numbers, so we don't have to write real. Number 2, we have negative 2.5. So this is a decimal and it's negative. So if we go back and look at the chart, it's not a natural number, so it's not a counting number because it is a decimal, which means it's also not a whole number because whole numbers are all the counting numbers plus 0. And it's not an integer because integers are whole numbers including positives and negatives. So the negative 2.5 is just a rational number. Number 3, we have a repeating decimal, and oftentimes with a repeating decimal, students are tempted to say irrational, but repeating decimals are actually rational numbers. We know that decimals are just rational. They are not integers, they are not whole numbers, and they are not natural numbers. But if it's a repeating or a terminating, then it is a rational number. Number 4, we have the square root of 38. And the first thing you should ask yourself, is this a perfect square? Is there a number that you can multiply times itself to get 38? And the answer is no. So the square root of 38 is irrational. 5, we have 0.7. So this is a terminating decimal, which means we could write it as a fraction, 7/10. So this is rational. Again, decimals will never be integers, whole numbers, or natural numbers. For number 6, we have negative 6. And if we want to go back and look at which part of the chart the negatives begin at, those are integers. So negative 6 is not a natural number and it's not a whole number, but it is an integer and it is rational. So we write integer, rational. So let's look at some examples where we compare different numbers. So you're replacing the dark circle in the center with either a less than, a greater than, or the equal to symbol. And on an example like this, you actually could use your calculator to help you estimate. But we know that 3 1/3, if we write that as a decimal, is 3.3 repeating. And now the square root of 15 is not a perfect square. So if you put that into your calculator, the square root of 15, you get 3.87 dot, dot, dot. So now it's a little easier to compare the two numbers. We have 3.3 repeating and 3.87. And hopefully you're recognizing that the first number is less than the second number. So it's 3 1/3 is less than the square root of 15. For number 8, we have 7 2/5 and the square root of 57. So 7 2/5 is the same as 7.4. I know that 2/5 is the same as 4/10, so that's 7.4. And the square root of 57 is 7.54 dot, dot, dot. So that's enough information for me to understand that 7 2/5 is less than the square root of 57. Example number 9, we're ordering these from least to greatest, and it's probably easiest if you put these all in decimal form so that you can compare them. So 8 4/5, I know that that's 8.8. If you're not sure, you can do 4 divided by 5 in your calculator. That's 0.8, and so it would be 8.8. The square root of 64, that is a perfect square, and it's 8. 8.3 repeating is already in a decimal, and the square root of 76 in my calculator is 8.71. So I want to order them from least to greatest. So the smallest one is the square root of 64. Then we have 8.3 repeating. Then we have the square root of 76. And finally 8 4/5. So again, when you're comparing numbers, as is always the case, you should make sure that each number is in the same form first so that you can compare them. Now let's look at solving some equations. Now we want to solve equations using square roots. So by the definition of a square root, if x squared equals y, then we can square root both sides, and we find that x will equal plus or minus the square root of y. And you can use this relationship to solve equations that involve squares. So for example, we have a squared equals 36. And you have to remember here that square roots and squaring are opposite operations. So square rooting and having something squared are opposites. They undo one another. So if we square root something being squared, those two things cancel each other out and you're just left with a. Well, as is always the rule with equations, if you square root the left side, you have to square root the right side. We have to be very careful here though, because notice the plus or minus sign. And we talked about this in the last set of notes. But when you square root a number, you actually end up with two answers. Because positive 6 times 6 is 36. And negative 6 times negative 6 is 36. So our answer will be a equals, and remember that's read plus or minus. So a equals plus or minus 6. So I want you to solve each equation and round to the nearest tenth. We'll be rounding when the number is not a perfect square. So for number 10, y squared equals 81. Again, we want to square root both sides because the square root cancels the square. And we get y equals, and our answers will always be plus or minus. So get in the habit of writing that. But the square root of 81 is 9. So we have two answers here, positive 9 and negative 9. But we can write it plus or minus, so it saves us a little time. Number 11, n squared equals 85. So we square root both sides. The square root and the square cancel each other out. So we get n equals, and 85 is not a perfect square. So if I square root both sides, or if I square root 85 in my calculator and I round it to the nearest tenth, I get 9.2. And remember again, it's plus or minus because we're talking about positive 9.2 and negative 9.2. Squaring either of those numbers will give us 85. Number 12 looks a little different, and I should explain that before you can square root both sides, you must get the variable by itself. So before I can square root this, I have to divide both sides by 3. When I divide both sides by 3, I get d squared equals 121. Now when I square root both sides, I get d equals plus or minus 11. The square root of 121 is 11. And remember again, it's positive and negative. On number 13, again, we want to make sure we get the x squared by itself first. That 2 is being multiplied, so we want to divide both sides by 2. 60 divided by 2 is 30. When I square root both sides now, I get x equals plus or minus. 30 is not a perfect square, so when I put that into the calculator and I take the square root of 30 and I round it to the nearest tenth, I get 5.5. In my calculator, it says 5.47, and the 7 rounds the 4 up to a 5. So we've been able to identify and compare numbers from the real number system, and also solved equations using square roots. In class, we'll work on worksheet 10.